Class, we are live now.
Awesome. Great. So let's kick it off then. Start a bit slow so everyone can join. But good afternoon, everyone, or evening or morning, depending on where in the world everyone is. Thanks for making it to this Adversary Guru stream. My name is Cas Van Cooten, and I'll be talking about NIM malware today, which I do a lot if you follow me on Twitter, if you happen to follow me. Um, so yeah, get settled, get something to drink. The next 45 minutes to an hour or so, we will be doing some fun stuff with NimPlant, which is my newly released tool. So really briefly about me, my name, as I mentioned, is Cas van Cooten. I'm based in the Netherlands, red teamer at a big bank here. Um, in my work as a red teamer, I also like to focus on malware development. Yeah, basically in red team ops, and I've spoken about this in the past as well. We see that um, off-the-shelf tools don't cut it as much anymore, right? So malware development is becoming increasingly important. And for that reason, I've also started picking it up more over the last couple of years. Specifically, I like building malware in the NIM programming language, which I will introduce in just a minute, which has some really nice advantages if you're not that familiar with low-level languages like I was in the beginning. And as a result, I've also created and published a couple of tools in the NIM programming language. I've published NimPact before, which is a NIM-based packer and shellcode loader, basically. And I've just recently, a week or two ago, I think, open source NimPlant, which is a first stage command and control framework or tool, I should say. It's not really a framework technically. So we will be talking about that today. You can mostly find me on Twitter as well, where I mostly post memes and sometimes something useful in the offensive security discourse. And I'm also on other social media, of course, and more notably, my tools and also slide materials for talks that I do and stuff is all on Discord. So, is it Discord? GitHub, of course. So feel free to check me out there as well. So last DEF CON, I was invited to speak also on the topic of NIM at the Adversary Village we had there, which was a lot of fun. Maybe some of you were there, in which case you will recognize some of these slides as well. But yes, I want to recap a couple of themes I touched upon there, just to introduce why I even started writing a command and control framework in the NIM programming language, while there are already hundreds maybe out there. And one of the themes that we see, which I already briefly mentioned just now, is that as a red teamer, it's becoming less and less useful to just use off-the-shelf tools, right? So there's a lot of people publishing tools on GitHub that are very, very useful. But if you just try to use them as is in operations, that's not gonna cut it anymore. So as a result, us red teamers are being driven more towards the development side of things. And as the time progresses, we also see that that threat actors are resorting to novel methods of malware development. So there are actually a lot of articles out there. There's a couple on the screen that show trends towards newer development languages for malware development. And that's quite interesting, right? Why would people go towards these newer languages? Um, th- that's a question we can talk about for a much longer period of time. But I think in general, the advantage of really picking up a new language for malware development is that defenders also are not familiar with these languages, right? And we've seen this trend with languages like Go. We've seen it with Rust, which both use like a LLVM type compilation, which is of course harder to reverse engineer. And we've also seen it with NIM. So yeah, we've seen the trend that people are picking this up for malware development. As I mentioned, it can happen and actually happened with all types of languages, right? And it also doesn't mean that the classic languages like C, C++, whatever, assembly even, are not used for malware development, because those are, I think, still the most prominent. But it's an interesting trend to investigate and to talk about. Um, so as I mentioned, myself, I prefer writing in the NIM programming language. Really quickly, for the people that haven't heard of NIM, it has a couple of advantages, and we'll be zooming in the advantages for malware development specifically. Just to understand also better why NimPlant is an interesting tool, right? So one of the big advantages is that NIM, it's actually, yeah, it transpiles to native languages. By default, that is C, which means that if you write your code in NIM, which looks very different from C, as we will see in a minute, um, under the hood, it will actually translate it to C and then compile it into a native binary. And that's interesting because it basically at that point is a native binary, right? There's only a few traces that you wrote it in NIM, but it also means that it's very lightweight. And we also see that here. I mentioned Go, for example, produces really large binaries, infamously large, actually, because it uses like a LLVM compiler. And NIM doesn't rely on that. It's all native, so the smallest binaries are actually really small. You can keep it under 200 or 300 KB if you would really want to. So that's a big advantage. There's also other options. You see C++, Objective-C, JavaScript. NIM is also really good for cross-platform compilation. So that all makes it easier to use. And also, yeah, switching up the compiler that you use or the intermediary language may aid in evasion as well. The syntax is actually one of the main reasons why I started looking at NIM in the first place. It's really inspired by Python. I happen to love Python. Of course, there are a variety of opinions on it, especially in the malware development space. But Python, in my opinion, is one of the easiest to write programming languages. And because NIM actually inherits some of those properties, it feels more familiar, and it also makes you faster in writing the language, right? Which in my opinion is a big win, because whenever I start writing C or C++, basically I'm just troubleshooting all the time, trying to see what errors I made this time and fixing them. And when I write NIM, it feels more natural, and it's more guided in a sense. So it's a bit safer. And the big reason for me is using NIM so I don't have to write C or C++. And that's kind of a controversial opinion, I know, but yeah, sue me. One of the other reasons that make NIM very attractive is the foreign function interface. NIM has a really mature foreign function interface, and what that means in practice is that it's really easy to interoperate with something like the .NET, the language runtime, the CLR, for example. It's also really easy to interoperate with Windows operating system internals. And as a result, it's also easy to write low-level code that does things like, take the easy example of shellcode injection. The NIM has this really mature interface, which makes it just easy to access these properties, which we will also see being used in NimPlant if we have the time to cover that as well. Mentioned this one already, easy cross compilation. I called out MinGW here, which is what is used to compile two windows from Linux in the case of NimPlant. But there's more options as well. You already saw Objective-C, so you can use NIM to program on Windows for Mac OS or something if you would so desire. So what does it look like before we jump into the hands-on part? This is a small snippet which I stole from the Rosetta Code website. What it does is not really too important, but I think if you would look at this, one of the first thoughts that will pop in your head is, wow, this really looks like Python. And I think that's a nice example of yeah, what Nim looks like, right? You see the imports, for example, of the standard library in this case, a couple of variable definitions. Interesting to note is that Nim is strongly typed, so every variable has a fixed type, but it does have type inference as well, which you can see being used here. For example, the new HTTP client is an HTTP client object, but it's not explicitly defined here. And Nim is, of course, clever enough to infer that from the code that you're writing. Also see some string operations here, substrings, string concatenation, subranges, things like that. Again, not too interesting. I just wanted to show the point a little bit that yeah, Nim is really Python-like, which is a major selling point for it. Great. That's about it for the talking in slides part. Because today I wanted to focus mostly on my newly released tool NimPlant, which we can play with a little bit. I can show you yeah, how it works, some of the code and internals behind it, and basically yeah, get hands-on with it. So also people that are hanging out in the Discord, if you have any requests or questions, please ask them while we go. Let's make it as interactive as possible. To introduce NimPlant a little bit, already mentioned it just now, but basically what NimPlant is it's a command and control implant, which means it has a yeah, client side, which is essentially the malware that you're installing, right? That's the implant, which we call obviously NimPlant because that part is written in Nim. It has an accompanying C2 server, which is used to control the implants remotely. That part I wrote in Python, basically because, well, as I mentioned, I am most yeah, familiar with Python. So writing that part in Python just makes it a bit quicker. And for example, the web libraries like Flask are quite a bit more mature in that front as well. So that's why I split the languages in this case. It also has a graphical user interface, which is web-based. Doesn't support authentication or explicit multi-user operations at this point, just because it's just a early access implant. But it can be used to control the implants also remotely from the server, right? If you're not at the console, you can use the graphical user interface. And it also has a couple of features that yeah, that make the usage of the tool, like the usage of beacon object files, a little bit easier as an operator. And we will get into that in a minute. So NimPlant is what I called before a early stage 0, stage 1 implant. There's different terms for it. What that actually means is that NimPlant does not aspire to be a full command and control framework like Cobalt Strike or Sliver or what have you. It essentially targets the stage where you have just realized execution or you have a successful infection, for example, after phishing a target or something like that. And it aims to be the lightweight payload that you deploy before going towards the bigger and more notorious command and control frameworks. Why would you do that? Basically to gather information, right? If you want to deploy more, yeah, a notorious malware, for example, you basically want to do so in the safest way possible, and that means applying execution guardrails, maybe only executing if it is run by a certain user, things like this. And in some cases you can't have that information. So NimPlant was initially, at least, just a information gathering framework. But once I started working on the project a bit more, I also started implementing more opportunities for actual execution and, for example, passing execution from that early stage operation to the later stages. And it also implements even more risky features like the execution of .NET assemblies in the current thread, beacon object files, things like that. So you could run whole operations with it. I'm not sure if I would do that myself, especially longer running operations. Usually it's nicer to have the big fat frameworks as well, but it's definitely possible. It's HTTP based, HTTP or HTTPS, of course, which is fairly common, I would say, in the command and control frameworks. In that sense, it doesn't really implement anything new. Of course, there's some configurability in terms of the communication behavior and the endpoints that it uses and so on. But I would say that it's advisable to either tweak that in the code itself if you really want to use it during operations, and of course use redirectors as well, because to prevent abuse, there's also some behaviors in NimPlant that may give away that you're actually using a NimPlant for defenders as well. So for the red teamers watching this, maybe we'll get into, if we have time at the end, to the things that you can tweak to make it more OPSEC safe, as we call it. Finally, the native implementations. I try to make everything just written in Nim, right? Which makes it so that it's not dependent on things like a shellcode injection to get I don't know, something patched in memory. Of course, the latter behaviors are quite suspicious if you see them. But implementing things natively in just the way that that normal programs would do them, so to say, makes it a little bit less suspicious. Of course, that doesn't go for the suspicious functionality that I just mentioned, like beacon object files, but that's why those are compiled into the framework separately, so that if you just need that information gathering functionality, for example, you can leave all the dangerous functionality out of the implant. It won't be compiled in there, so it won't be available. But it also makes your implant a bit safer to use. That looks a little bit like this. So you can see the web front end on the left and the console as well. But I would propose that we get into the hands-on part now. So I see that my VM got suspended, so let's start that up. I just installed a new computer, so all the configurations are still at default. So let's hope also the demo effect, the demo gods are with us today. In the meantime, if there are any questions, Q&A is in the Adversary Village Discord. There's a channel called Live Stream Q&A, which I have on my monitor here. So if you have any questions, feel free to ask them there, and requests as well, of course. So NimPlant. What we see here, let me full screen this so we don't have all the toolbars. What we see here is the GitHub repository. That's github.com/ch Van Cooten, which is me, slash NimPlant. It's open source now since a week or two. We're up to version 1.1, and in the dev branch, I'm working on the more experimental features in the for version 1.2. So if you want to play along or want to play with NimPlant afterwards, feel free and pull down this repo. I tried to make it the documentation as complete as possible. I'm sure it's missing some things, but in terms of the steps you need to install the framework, install all the dependencies, and basically, get up and running, the steps are all there. It also has an explanation of the configuration, some tips and tricks for compilation, which we will walk through in a second as well. It supports Docker compilation, which is especially useful on Linux, I would say, just because there's quite a lot of dependencies, right? You have Nim, you have Python, you have certain Nim packages, and on Linux you have the minimal GNU for Windows cross compilation stuff as well. So using this Docker container, the Nim build Docker container by me, which is available on the Docker Hub. Using that just minimizes the possibility of error. So if you encounter any issues or you don't want to install all this stuff on your host system just because you're only going to play with it once, for example, I would recommend using Docker. Let me make this a little bit bigger so it's easier to read. Usage, of course, some tips and tricks on using the framework, as well as some behaviors. Won't go into everything here today. Also, don't think it's too relevant, but yeah, if you really want to use NimPlant during production ops, so to say, do ensure that you read all of this and that you go through the code to verify that everything is behaving as expected. Because otherwise, yeah, that's not a very good practice. The commands, we will walk through those in a minute as well. Usage of beacon object files, so we will also demonstrate. Supports push notifications if you so desire. Front-end modifications shouldn't be necessary, but if you want to have a custom fork where you add a functionality to the front end, you can also dive into the JavaScript side of things here. And that's about it. So yeah, it should be fairly easy. Again, NimPlant available on GitHub. So if you want to run along, pull it down now, I would say. And let's actually walk through the steps to get up and running. So I pulled a fresh copy of the repo here. At least I hope it's fresh. And we can go through the steps to actually get started with the implant. So the first thing we have to do, and it will also say if we run the main script, is basically the nimplant.py is a wrapper to make it easy to do anything related to NimPlant. And it will tell us that we need to create a configuration file, right? This is based on the example. So if we copy that, and I'll just open it in VS Code here, so we can see it a bit easier. Can I zoom in as well? Yes, I can. So we have the configuration file here, and the configuration file is shared between the implant and the server. So keep in mind that anything that you configure here must match for the implant to be able to find and connect with the server. You can, for example, in the case of using forwarders, you may need to change some stuff between the compilation phase and the running of the server phase, but normally this shouldn't be required. But keep in mind that this needs to match. So especially if you're compiling and running the server on different machines, make sure that you keep an eye on that. It's a fairly basic TOML file. I put comments in there to make it a bit easier to configure as well. First section is about the API server and the web GUI. So typically, I would recommend not to change any of those settings, especially the IP. You can change it to, for example, 0000 to expose it on all interfaces. But as I mentioned, the web frontend does not have authentication. So definitely not recommended unless you have something like a reverse proxy enforcing authentication on the web GUI. Oh, that's the wrong screen again. So in general, I would just keep it localhost, and if you want to access the GUI remotely, just use SSH port forwarding or something. Port speaks for itself. Then we get to the listener configuration. As I mentioned, NimPlant configures unencrypted HTTP and HTTPS. If you want to use the secure variant, you also have to pass your certificate information and key. Typically, if you have something like Let's Encrypt, you would just pull it from there. You can also self-sign. Wouldn't recommend that if you directly expose NimPlant, but for something like a reverse proxy or a forwarder, it should be fine to do that. Host name is used if you have a domain tied to your machine. So if you host your NimPlant on attacker.com, for example, we can add it. Worth noting that if we leave this empty, NimPlant will essentially try to connect with the IP and the host name. So in this case, if we leave it empty, we will set it to localhost, just because we're just running local testing. But if you leave this empty and you want to expose it, you have to put your external IP address here, because otherwise NimPlant won't be able to find it. If you have a host name here, like attacker.com, it's fine to leave it at quad 0 to expose it on all interfaces as well. As I mentioned, we will leave it localhost for now. Then we have the bits and pieces of the HP endpoint configuration. There's a couple of paths of the listener server that NimPlant interacts with. Yeah, they are literally used for registration, getting tasks, and returning results. You can easily change those. As I mentioned, if you want to stay under the radar a bit more, would recommend looking at the actual server file, which is in the server folder. It's called listener.py. That's where the kind of yeah, listener internals are. It's just a Flask server, so it should be quite easy to adapt, more than it is adaptable via the config. But for initial configurations, this is fine. And for this demo, we will just leave these as is. Finally, we get to the NimPlant configuration. So this is the configurations of yeah, the actual implant that you will compile, right? So this is what will run on the victim. First of all, we have the risky mode. This is what I mentioned, that we can compile the dangerous functionality separately from the pure stage 1 functionality. So if we don't have any need to run assemblies, BOFs, or inject shellcode, we can disable this. Normally, I would keep it enabled, because yeah, you never know why you would when you would need this functionality. But yeah, it's good to have the option, I would say. There's a sleep masking functionality as well. This currently only works for binary executables and not for DLLs. We'll get into the compilation output files in a minute. But keep that in mind if you want to use this. It's kind of nice that you can get rid of the normal sleep calls. For now, it's not necessary as much, I would say, because NimPlant is still quite new, and the signatures are still catching up. So there are currently signatures for most of the binaries in the default config, but I don't think there are any memory signatures for NimPlant yet. At least I haven't encountered them. So encrypting the memory while we are sleeping is not that necessary. But I added the option for for the long run, once an implant becomes more suspicious in the eyes of defensive products, we can use that feature as well. Of course, you can also bring your own shellcode loader to patch the sleep calls that NimPlant uses. It's up to you as an operator. Sleep time, this is the initial sleep time that NimPlant checks in with. Would recommend setting this a lot higher, because this is only for the first check-ins. You can change it, of course, at runtime. But just for the demo, I'm going to set it to 5 seconds, so we get a bit more interaction and more things to play with. Jitter, if you ever played with Cobalt Strike or something, you will be familiar with that as well. And there's a kill date as well. Good practice to set this during operations. If you know your operation ends at a certain date, you can set that as a kill date. And if there is ever a execution of the binary after that point, it will basically do nothing. So it will be neutered and harmless. So good practice to set it. In this case, it's just very far in the future, so we won't uh, accidentally neuter our implant. Finally, we have the user agent. This is what the implant uses as a user agent to connect to the server. Um, Good to note that this is used also in part to verify NimPlants. It's not used as a authentication because there's a key exchange and yeah, a validation of the encryption basically, which we can touch upon later if we have more time. But the user agent is used as a part of the check just to keep nosy maybe IR responders or something that do not set the right user agent away from your server. Basically, everything that does not match this will get a, I think it's a 404 by default. So that can be useful to protect your implant as well. Of course, having a very different user agent like a NimPlant C2 client is a indicator on itself. So I would recommend choosing a legit enough user agent here that you won't stand out in proxy logs. But also one that isn't too widely used, just so you don't have accidentally allow people to interact with your server. So that's it for the configuration. Once we did that, we can start compiling our implants. So compiling is, of course, the phase where we yeah, generate the artifacts, the binaries that we want to use in our operations. So to do that, we can use the same NimPlant script, and we can use the compile option. Now there's a couple of formats. In this case, I will just choose all to compile everything. But yeah, you can also say, for example, compile exe to yeah, only compile the executable. You can also add nim-debug at the end to compile a debug binary. This will have like a screen where you can see the error messages and whatever of the NimPlant on the implant side, which is of course good for testing if you're adding or tweaking functionality or if you're encountering unexpected behaviors. But definitely not recommended for real operations. So as you can see, compiles fairly quickly. Because this is the first run, we also generate a XOR key. This is used in the key exchange phase. So this, yeah, essentially unique for every NimPlant installation, right? Which makes it a bit harder to reverse for example, the configuration that's in the NimPlant, or if a operator or the responder catches the traffic, the initial key exchange traffic, also harder to reverse that. Again, important that this file matches if you compile your artifacts on a different server than where you yeah, use the agents or where you run the server. So if you have those separate, make sure that the .xor key file and the config.toml match, because otherwise you will get connection errors once you trigger the implant. And that's about it. You can see that the artifacts are compiled to client bin. We have all of them here. As I mentioned, there's a couple of different formats. Most straightforward one is the executable. Yeah, just the run-of-the-mill .exe. Wouldn't recommend using .exes in operations, but yeah, if you can get away with it, why not? Alternatively, you can use something like Donut to convert this back to shellcode if you so desire. There's a library as well. By default, this is exported with the update function. Would recommend modifying that as well if you want to use it. Also, you can tweak if you want to sideload or hijack with DLLs. You can use this one, but it will require some modifications to the DLL main function by default. If you're struggling with this in NIM, just yeah, feel free to reach out. It's quite easy to do and also well documented. We have the shellcode file. By default, NimPlant generates shellcode, position-independent shellcode using the SRDI method, so reflective DLL injection. And this can be used in, well, for example, packers or shellcode loaders to trigger NimPlant in a more obsec safe way. I made a conscious decision not to put all the evasion features that you can have in a loader into NimPlant, just as a kind of separation of concerns type consideration, right? If you have a shellcode loader, you can think about payload keying, about encryption of the shellcode itself, sandbox evasion, all these types of things. I don't really want to start putting that in NimPlant because then it will be very bloated, very suspicious as well. And yeah, in the end, it will just be fingerprinted as well. So for real operations, would recommend that you take the shellcode file, maybe even generate your own shellcode, which does not use reflective DLL injection, and use that in your own OPSEC safe loader to get execution on your victim machine. Finally, there's one additional method, which is an executable, but it's a self-deleting one. This works a little bit better for yeah, evasion, because it will basically execute, load itself into memory, and then remove the disk artifact. Just a nice trick that's fairly easy to implement in NIM. So I added that there to just to have it as an option. But in essence, it's just the same as the binary executable. So those are the artifacts that we have. Now it's time to spin up the server itself. Also easy to do, just use the same NimPlant command and pass it the server argument. Again, as mentioned, reads the XOR key value and reads the configuration. So if you have those steps separated, make sure that that those match. And when we do that, we see that there are two servers being spun up on our machine. These are on the one hand the yeah, API server and web GUI, and on the other hand, it's the listener that we have. So normally this wouldn't be running on localhost, because yeah, we need traffic to get to it. Just for demo purposes, it is local only. But as a first step, we can navigate to our web front end. And you can see the beautiful GUI that I'm very proud of, because I'm definitely not a web developer, but using Next.js, it was actually really easy to make something like this. And you can see that on this port, we have the front end. A couple of things there. We have the server information there, which shows the default configuration for the server and NimPlants that we'll be checking in. We have the console, in which we can see messages that are not tied to a certain NimPlant specifically. And that's basically all we can see now. We also have a downloads view and a NimPlants view, but of course, at the moment, we don't have anything checking in. So yeah, we need to trigger our NimPlants before we can work on that. And thanks, Abhijit, for, good to see that you like the UI. Also worth noting that NimPlant is also console-based, so if you prefer just the textual approach, it's possible to just completely disregard the UI and do everything on the command line. So let's actually start by showing that, and then we will get to the UI. So the artifacts are in client bin. For the demo, I will just use the normal executable. It's easiest to show the other methods essentially um, uh, load the same code, right? But they just differ in the way how they load it. And immediately we see that the NimPlant is checking in, and we get some initial information. The console, as I mentioned, has everything here. If we have multiple NimPlants, we can switch between them using the select command, and saying invalid NimPlant ID. Let's see, list, I think, is the NimPlant list. So maybe if we select this, then we will see that we switch between NimPlants. I'm not sure why it doesn't. It's a demo effect again. Haven't checked this function for a while, so it's all live. But we can see that we can switch between NimPlants and essentially, yeah, run commands on all of them without leaving the comfort of our terminal. You can also see that there is a history autocomplete. We can help. There's tab completion for local files and for commands as well. So it's fairly easy to use via the console. But just because some things, for example, buff loading or shellcode injection, are a bit harder to do when you're not working from that local server, I decided to add the front end as well. And you can see that the NimPlants that we saw checking in the console have also appeared in our front end. So essentially, we see the same information here, right? We see the process name, process ID, username, and host name. Fairly standard, all of this. This will always show less than 5 seconds ago because, well, their sleep time is 5 seconds. So that's not too interesting here, but it will also, yeah, this is dynamic. So if we check in a new implant, we will see that without refreshing or anything like that, it will pop up here. So let's interact with one of the NimPlants. You can see that, yeah, the history is of course shared between the console and the implants. So you can also have one operator running the console, the others interacting with the web GUI as well. Let me see if we can zoom in a little bit. So again, for NimPlants, we have the NimPlant information, which well, essentially gives the information specific to this NimPlant. We can also kill it if we want to. Let's not do that because that will be a short demo. And yeah, that's the same information here. Of course, if we want to, we can change the sleep time. Will be reflected here as well. This is all real time. So let's actually show some commands. Again, you can see that there is tab completion here. There's also yeah, more options to choose from if you want to. This is both from the command list as well as the command history. So if we go back, or we type a post command, let's say, we can also autocomplete that. In this case, not very useful. There's history in the command line as well, which is synced between clients. So it is pretty usable as a console. Yeah. So looking at the commands, I'm not sure how. I think it's readable enough on the stream. Can make it a bit bigger as well. Um, there's quite a list of commands. Every command has a short help and a longer one. So, for example, if I want to get more help on the execute assembly, I can type help execute assembly, and it will get the more extensive help. If a command is marked as risky, that means that it's only compiled if you have risky mode enabled, which is the default. And if it's marked as GUI, that means that we can use modals to actually interact with it, which I will show in just a second. But just going through the commands, basically we see that there's a lot of utility commands to get information. So for example, we can easily get the antivirus that's installed, the domains, local admins, information about the NimPlant, environment variables, stuff like this. There's quite a focus on that because, of course, it is designed as a early stage implant. So having these information gathering commands at your fingertips in a native implementation is pretty nice. Most of it can also be done with beacon object files, but yeah, the native implementation, of course, is easier to use and yeah, OPSEC safer as well. There's file operations, so we can download files from NimPlant to our server, which will be accessible here. I can show that in a second if you want. You can also upload files. So if you want to drop persistence or drop a Cobalt Strike beacon, we can do that. There's a command to interact with the registry, and of course we have the risky commands as well. So I think the most notable ones are execute assembly. This is of course similar to the infamous Cobalt Strike command, with a big difference that NimPlant does not use fork and run. So it actually loads the CLR, which is the .NET runtime essentially, into the current process. So be cautious of that because it can be a dead giveaway if notepad.exe, for example, starts loading that runtime. But it can also be really nice if you're already in a .NET process, for example, through process injection or whatever. this will be yeah, quite hard to detect because the assembly itself will be running from within the process. So it's yeah, it's a bit nicer than the fork and run approach in that sense. Inline execute, of course, being the beacon object file command, also quite involved in terms of arguments, but that's why it's a GUI command just to guide you through it a little bit more. Let's see what other we have. Shellcode injection, which uses a dynamic invocation of yeah, the Windows API essentially to run shellcode in a different process. So it can be used to spawn new NimPlants or to also inject your Cobalt Strike beacon, for example. And I think that's more or less it for the risky commands. I think I'm missing one, but that's all right. So let's actually start running some stuff. Maybe first let's start with some basic file operations, right? So one thing that we commonly want to do is we want to know where we are on the file system. In this case, we are in the NimPlant directory, so we can see what is there. And maybe I should actually lower the sleep a little bit more, just so we have a quicker beacon. We can see that the files are here, right? So we are in the directory where our artifacts are, so that makes sense. So in this case, we can download, let's say, the self-deleting executable. Can use the full path here or any relative path. Of course, it just uses OS native APIs to move around, so it doesn't really matter what you use. So because we didn't specify a download path, it downloaded to a default directory for the specific NimPlant here. And that's basically because that's where the web GUI reads the downloads from, right? So in this case, we can see we downloaded this file from this NimPlant, some information about it when it was downloaded, and so on. And if we click it, we download it to our local machine. So even if you're not operating on the server itself, you can download it through the web front end. In a similar way, we have the screenshot command. If we run that, it will take a screenshot and store it to that downloads directory. So if we want to see what's on the screen here, we can open that screenshot and see that, well, yeah, it's a screenshot of us taking a screenshot, screenshotception. So that's kind of how you interact with files via the web GUI. The reverse of that is also true. We can run the upload command, and if we do that, we can actually use a modal. As I mentioned, some commands are GUI commands. They use modals to essentially interact with that command. For the upload command, that's yeah, it makes sense, right? Because we need to upload a file to the web front end. So let's upload this Wireshark installer. No, that's 76 megabytes. It's probably going to break something. So let's upload the screenshot that we just took and upload it to lol.png. And in this way, we will actually post the file to the API server, and NimPlant will send it along. So if you're using the web GUI, this is how you interact with files and everything. And if we list the files, we can see that the file is put in the directory. All makes sense. So let's start doing some more interesting stuff. I think one of the nicest examples is the inline execute command, which is as I mentioned, the beacon object file feature. This is quite essential if you want to use NimPlant for more advanced operations. On the one hand, because yeah, beacon object files are becoming more and more prominent, right? It's a lot safer than using fork and run or shellcode for everything. So yeah, using BOFs is the way to go when it comes to a lot of operations. But using them is usually quite complicated. They have been designed for Cobalt Strike, so that means that there's some interoperability on the arguments that we need to pass and everything. That's a bit of a pain from the command line, but using the GUI, we can actually make it a bit easier because we can just add the arguments as we go, and there's a drop down for the argument type that we have. So depending on the beacon object file that you want to use. Sometimes you have no arguments, sometimes you have multiple. So yeah, this is just my way of making it easier to interact with. I hope I have a beacon object file here. Yes, I do. I have the create remote thread beacon object file from the Trusted Sec remote operations beacon object files. Really recommend those, by the way. Both there's two Trusted Sec repos. One of them is the remote ops, and the others is the forgot the name, but it's more the situational awareness type beacon object files. So any functionality that's missing in NimPlant, you can use BOFs for. In this case, we have an injection BOF. If we would look up the repo and see what arguments it takes, we would see that it takes two arguments. One of them is the process ID we want to inject in, and the other is well, the binary blob of the shellcode. And I'm going to cheat a little bit and look at the README because I happen to have an example of the shellcode injection via BOFs here, just because I don't have this base 64 string at the ready otherwise. So binary commands can be passed raw or as base 64. Normally you would want to do it base 64 because otherwise you're definitely going to have bad characters, right? If you're pushing a binary payload that's yeah, that's shellcode, for example, it's full of bad characters. So usually you would want to pass this as base 64. Depending on the BOF, may also expect some other arguments, but in this case we only have the process ID and the yeah, and the payload, or sorry, the process ID. No, yeah, process ID and payload. There we go. So I'm gonna cheat a little bit here and grab a process ID that we can inject in, because yeah, let's take that. Why not? 7128, I think it was. And let's run this both with the shellcode that we had. You can see that went fairly quickly actually, but we executed the beacon object file. We can see the output here as well. So it's using, of course, the normal beacon print out. I think those types of hooks to print output to the console that will be returned to the operator. And we see that in this case, the shellcode that we had, which the base 64 that I have here is just the I think it's a Metasploit calc shellcode code, quite a small one. That got executed. Of course, a bit of a weird example because shellcode injection is also in NimPlant itself. It's in the sh inject command, which is also a GUI command. But just to demonstrate the beacon object file functionality. As I mentioned, it should work with yeah, basically any beacon object files. Also keep in mind that the entry point function is correct here, but commonly Go is used. So if you're in doubt, you can leave that as default. And if you want to use other buffs, I would recommend looking at the implementation of the buff to see what arguments it's expecting. This is also discussed in the README. There are some cases, for example, that passing no arguments at all will crash the buff, whereas if you pass a empty string as an argument, that will work. So definitely always test your buffs before deploying them. And yeah, just make sure that they work as expected, both as in a BOF sense and from NimPlant as well, because this is a Nim implementation of the BOF loader, which is called Nikov, if I'm not mistaken. There you go. Really nice implementation, by the way. If you're interested in Nim for offensive operations, look at the way it implements this. It's really nice. So I basically just stole that. So thanks for that. But yeah, that's I think the demo I have here. There's a couple of things we can dive into a bit more if you guys want. But I see we have about 5 minutes left now. So if there are any questions in the Discord, I would like to give the floor to you guys. Only see gifts for now. Right. Yeah. So that's a good one. The recommendations for using NimPlant in production. Hinted at it at the beginning. Of course. Let's take a couple minutes to talk about that. If there are other questions in the meantime, feel free. So when using NimPlant in production, number one recommendation is use a redirector. This is of course good practice for all listeners, all command and control frameworks, because it gives you a layer of obfuscation, right? If a web crawler finds an Nginx server, it's not that interesting. If it finds a server with the banner of NimPlant, that's very interesting. So definitely use a redirector. Configure the configuration. So in terms of OPSEC, definitely change the API paths and change the user agent. Because the user agent, if your target is using a web proxy, will be visible, and it will definitely stand out if it has NimPlant in the user agent. There's a bit more. As I mentioned, I added some indicators to make the abuse of an implant hopefully a bit harder. One of them is this one. This strange variable in the listener.py file is actually used as the server header somewhere here. Which is decoded. Yeah, it's just obfuscated a little bit so it doesn't jump in the eye immediately. But somewhere here it's set as the server header. That means that if you expose your NimPlant server directly to the internet without modifications, the server header will be something like NimPlant C2 server. Which is not what you want, because there will be web crawlers, right? There will be blue teamers, but also things like Shodan crawling your server. So that will definitely make it stand out. So change that. If you want to use NimPlant directly, definitely change this. But again, would recommend using a redirector, Nginx, some kind of reverse proxy. So your NimPlant is only interacting with beacons that you know are legit, right? So only for certain paths, and otherwise it's just giving a normal website or normal error page that is not typical to NimPlant. Another thing is in the binary itself. There's actually a string in it that will also make your binary stand out. So if you look at the nimplant.nim file, which is basically the entry point of the source code for the implant size, we will see somewhere here there's a version constant, and that's echoed at the start of the execution. So normally you won't see it. As you saw when we executed as a user, we didn't see anything. But of course, this will show up in plain text in the binary itself. Which is also very, very suspicious. So definitely remove that if you want to use it in production. As mentioned, debug binaries will also have a lot of strings, but normally NimPlant uses string obfuscation, which will essentially at compile time change all the strings, garble them with I think it's XOR that's used by default. So at every compilation, this string will be changed into something else that's not easily readable. But this string will be plain text. So definitely remove that. Um, Other than that, it should be quite usable. As I mentioned, recommended also to bring your own loader, right? So NimPlant will be fingerprinted more probably in the coming time. So definitely use your own custom shellcode loader that uses these tricks like sandbox evasions, maybe patching the sleep function yourself to use sleep masking, process injection, stuff like that. You can bring your own and use the shellcode file for. Um, um, you can also change up the reflective DLL injection if you want. At the moment, it just uses the open source SRDI library. So if you change that, the memory behavior will also be a bit different. But that's depending on how far you want to go. Of course, these changes are the easiest ones you can do to make NimPlant usable. But if you are operating in really advanced environments with a mature EDR, mature SOC looking over your shoulder, definitely yeah, go into the more advanced evasions, and always test, have a test environment, preferably with EDR installed as well, and just see how it behaves, right? What does the network traffic look like? What happens if you transfer big files? Things like that, and also test from a execution perspective. So if you want to run above, I would recommend running that in a lab environment first to see if it actually behaves like you think it would. Because of course, if the BOF crashes or if a .NET assembly crashes in the current process, you will lose your NimPlant. So that's the basic OPSEC tips. Throwing the big rock, AV and EDR evasion experiences with NimPlant. That's a really good question. So of course, one of the reasons I started writing it at first was to be able to bypass AV and EDR a bit more. This is the advantage of writing your own offensive security tools, of course. But I'm very aware that publishing a project like this will also come with fingerprints. Um, as far as I'm aware, it's not too bad yet at the moment. So by default, I think it will score like a 10 on the virus total. We can actually check that virus total, because if you look for hashtag NimPlant, you will be able to see NimPlants that are caught with the default rule. Has been a while now, and we can see that if we look at this artifact, this one is actually really well detected, but it's hit or miss in terms of AV evasion. If you use the default, this is all generated using the default. So we can see that this one only scores a 4, for example. So depending on how you load it and stuff like that, you may have successes with the out-of-the-box version. If you make these OPSEC changes that I mentioned, you will already score a bit lower in terms of static AV detection. If you want to bypass even more, you can look at the Yara rules that are in the repo. So you can see some of the memory and on disk artifacts that it looks for example, and you can try to get rid of those to lower your detections. Of course, this is using default artifacts, right? And that's not something you typically want to do. Because if you use the NimPlant XE as it is compiled from the public version, that will be really easy to fingerprint for defenders. So if you bring your own loader and stuff like that, it will really help. Because the in-memory profile of NimPlant, I already mentioned, is not too detected currently. And I think that ties in also with the EDR side of things, where the EDR of course looks at behaviors, right? And so memory profiles and behaviors of a tool. So if you get the initial loading to work, so you get it past AV, and you get your victim to execute it in a way that does not trigger EDR, then I think with NimPlant you're actually in a pretty good spot for now. Of course, you have the kind of standard things that you have to look out for. It's standard HTTP. So if you have unencrypted HTTP, that may be suspicious. Things like that. If you use a default API path, that may be detected at some point. So you definitely think for every action that you're doing about your OPSEC. This includes also things like loading the common language runtime for .NET executables. That's something typical that EDR may catch, no matter if you use it, if you use NimPlant to do it or another tool, because the behaviors themselves can also be suspicious. But in my experience, it's still very usable. Tested it recently against Windows Defender, which I think seeks only one default binary at this point. and Defender for endpoint EDR as well. That worked pretty well in my testing. That's to say, of course, it didn't trigger any alerts. That does not mean that there's no telemetry, because there's always telemetry, and a good SOC analyst will be able to catch someone using NimPlant, just like you would with a custom and a non-open source C2 framework. But yeah, again, the operator side of things is kind of what matters there. I hope that answers the question. I see no more questions in the chat. So I guess with that, I want to thank everyone for your attention. Let's see, I will put up my details again on screen. If there are any questions after the fact, you can find me here, my blog, casvancooten.com. Mostly active on Twitter, so if you want a fast response, DM me on there. And again, this is my GitHub, so if you go there, you will be able to download NimPlant and play with it yourself. So with that, thank you very much. Have a nice morning, afternoon, evening, wherever you are, and hope to see you online. And let me know your experiences with NimPlant. Thanks.
Cas. Yeah, that was awesome, man.
Yeah, was it good?
Yeah, I need to talk